All right, let's go over the problem here on the do now. It says, which graph best represents a function with zeros of -2, -1, and 2? And what I'm looking for are the x-intercepts of the graph. We need to remember that zeros or roots or solutions are the x-intercepts of the graph. All of those mean the same thing. If you are asked for the roots, it wants the x-intercepts. The zeros are the x-intercepts. The solution are the x-intercepts. So when I'm looking at this, I'm looking for a 0 of -1. And if I have a 0 of -1, that means that my graph must cross the x-axis at -1. And D does, and that's the only one that does. So let's go ahead and look at the other zeros. A 0 of -2 means the graph crosses the x-axis at -2. And a 0 of +2 means it crosses at 2. Therefore, D would have been the correct choice. All right, to graph a polynomial function, we can do so by finding the x-intercepts and the y-intercepts. Several different ways that you can find the x-intercepts. You can do that by factoring, by the quadratic formula, if possible, if your polynomial is an x squared. But the one that we want to always use is Desmos. You can see on Desmos that I have shown the equation. I did not type in f of x. I typed in y is equal to, because we know f of x is the same thing as y. And from my graph, I can determine what my zeros are going to be. All right, so if I graph this, and let me make sure that I have it typed in correctly, which I do not. I click on the x-intercepts. I have -5, 0, and I have gone ahead and graphed it over to the left. I have -3, 0, and I graphed it. I have 3, 0, and I graphed it. So this particular problem has 3 x-intercepts. I then go down in my graph, and I can do that by zooming or moving the graph. And I find that my y-intercept is at 0, -45. Well, clearly my graph is not big enough, so I'm just going to put a dot down here as far as I can possibly get it. And then I'm going to draw an approximation as to what this graph looks like. All right, it goes up, and then it goes down, and then it's going to go through that y-intercept, and it goes up again. So when we're graphing these, they are not going to be exact graphs. They are going to be an approximation, and we can get the x and y-intercepts from Desmos. The definition of multiplicity is when an x-intercept occurs more than once. And that would be, for instance, let's say that we have the equation x squared plus 4x plus 4 equals 0. And I solve this, and I'm going to do it by factoring, and I get x plus 2 times x plus 2 equals 0. I break each factor down, and I get x is equal to -2 2 times. Okay, this would be an example of a multiplicity because you have the same factor in that particular polynomial. Now, if you're given a graph to determine the multiplicity, if the graph changes directions at the 0, the multiplicity is even. And let's look at this particular 0. When I follow the direction of the graph, it is going up to that point, and then at that point, it changes direction and goes down. So if the graph forms that little hump and it barely touches the x-axis, the multiplicity is even, which means you're going to have 2 of those, 4 of those, 6 of those, or so on. All right, if the graph goes through the 0, the multiplicity is odd. And an example of that would be this 0. The graph is not changing directions, it's going through that 0. So that means your multiplicity is odd. If you have odd multiplicity, that means it could be a multiplicity of 1, a multiplicity of 3, and so on. On this particular problem, we are looking at increasing and decreasing intervals. Increasing and decreasing intervals is when the x values, where the graph goes up constantly and down constantly. I like to think of it as a roller coaster. Okay, and as a roller coaster, normally you start at the bottom, you go up, then you drop down, and then you may go up again, and you may drop down. And this is what we're going to think in terms of for the increasing and decreasing intervals. So on the problem that I have showing, I'm going to, first of all, label my arrows. And the arrow on the left, and this is important, is always going to be negative infinity. It doesn't make any difference which direction it is pointing. It is negative infinity. And the arrow on the right is always going to be positive infinity. So if I'm following this graph, and we're always going to start on the left-hand side, if I start at negative infinity and I follow this graph to -2, it is going up. That means that this interval is an increasing interval. At -2, it changes directions. It goes down. All right, so down would indicate that this is a decreasing interval. And at this point, which is -3 on the y-axis, it is actually changing directions again, and it is going up, which would be an increasing interval. So this particular graph has two increasing intervals, and it has one decreasing interval. Which 0 must have a multiplicity greater than 1? And I have 3 zeros shown on the graph, and I've written a statement about each one of those zeros. All right, the graph goes through this 0, therefore the multiplicity is odd. And normally when we think of odd multiplicity, it's going to be 1 or 3. All right, the second 0 changes directions. The graph is going up, and then it goes down. It changes directions at that point. Therefore, that is even. And if the multiplicity is even, the smallest multiplicity it could have would be 2. And the third 0, the graph is actually going through that point. Therefore, the multiplicity is odd. So the 0 that would have a multiplicity greater than 1 would have been x is equal to 1. All right, we are finding the roots of this polynomial function, f of x equal x plus 2 times x minus 7 cubed. To do that, you're going to set each factor equal to 0 and solve. So you have a factor of x plus 2. When you solve that, you're going to get x equal -2. You have also a factor x minus 7, and this cubed means that you actually have 3 of those, which tells us that the multiplicity of that factor is going to be 3. So I set that factor equal to 0, x minus 7 equals 0, Add 7 to both sides, and I get x equals 7. Because I have 3 of those, I know that my multiplicity of 7 is 3. So the correct answer would be answer B. I have negative 2 and 7 with a multiplicity of 3. Identify each of the x and y intercepts of the function h of x equal x cubed plus 3x squared minus 4x minus 12. And to do this, we are going to use Desmos. You can see that I have already typed into the calculator my equation, my function, y is equal to x cubed plus 3x squared minus 4x minus 12. And I can click on the points to find the x-intercepts. The x-intercept is where it crosses the x-axis, and it's going to cross the x-axis at negative 3, 0, at negative 2, 0, and at 2, 0. To get the y-intercept is the point where the graph crosses the y-axis, and that is at the point 0, negative 12. So if I'm answering this question, I would circle negative 3, 0, negative 2, 0, 2, 0, and my y-intercept of 0, negative 12. Therefore, we can find those simply by typing it into Desmos. All right, when we are doing end behavior, we are identifying what happens on the right-hand side and the left-hand side of the graph. So what I would recommend doing on any of these is to go ahead and label your arrows. In this case, with end behavior, if the arrow on the left is pointing down, that is negative infinity. If the arrow on the left had been pointing up, that would have been infinity. So the direction of the arrow determines whether you are going to have positive or negative. So a certain way that end behavior is written, it is written as x approaches positive infinity and as x approaches negative infinity. X approaching positive infinity means that you are talking about the x values on the right-hand side of the graph, the positive x values. So everything to the right of 0. X approaches negative infinity is talking about the x values on the left-hand side of the origin, which are the negative x values. So what I have done in each one of these is I have labeled my arrows on my graph. I have here the arrow on the right-hand side, and this is the side that says x approaches positive infinity. The arrow is pointing up, therefore that is infinity. The left-hand side of the graph is x approaches negative infinity, and the arrow is pointing down, which means that it is going to be negative infinity. Now, what do those arrows indicate? The arrows indicate the behavior of y. So to fill in the statement, as x approaches infinity, y is approaching positive infinity, because the arrow on the right-hand side is going up. As x approaches negative infinity, which is talking about the left-hand side of the graph, the arrow represents the end behavior of y, and it is going down, so that would be negative infinity. All right, on the second one, right-hand side is x approaches infinity. The arrow on the right-hand side is going up, which means y is approaching infinity. On the left-hand side, this is what we're looking at as x approaches negative infinity. My arrow is going up again, Therefore, y is approaching infinity. And think about what that's saying. As my x values go on forever and ever, my graph is going up, which are the y values forever and ever. All right, x approaches infinity is talking about this side of the graph. The arrow says it is going up, which means y is approaching infinity. The left side of the graph represents x is approaching negative infinity, and the arrow is going down, which means it is approaching negative infinity. On the last example, on the right-hand side of the graph, as x approaches infinity, y is approaching infinity because that arrow is going up. On the left side of the graph, as x approaches negative infinity, y is going up, therefore it approaches infinity. All right, so we're going to take a roller coaster ride on this particular graph of the function f of x equal 2x cubed minus 3x squared minus 12x. I'm looking for the interval in which the graph is increasing. And what I'm doing is I am going to start on the left-hand side, and I'm going to go through the graph like a roller coaster and identify whether it is increasing or decreasing. So if I start at negative infinity and I go to negative 1, that graph is going up. Therefore, this would be an increasing interval. From negative 1 to 2, my graph is going down. And because it is going down, it is decreasing. And then at 2, it changes directions again, and it is going up, which means that this would be an increasing interval. So I have to determine which one of these represents an increasing interval. All right, so increasing, and I'm just going to write it in interval notation, is going from negative infinity to negative 1. And also, it is going from 2 to infinity. Decreasing intervals would be from negative 1 to 2. All right, so if I'm picking the correct answer, these are not written in interval notation, but I can take the information that I have and apply it to this. Therefore, x is between negative infinity and negative 1 would be the increasing interval. All right, first thing I want to do is I want to label my points. I have the arrows. On the left-hand side, it's always going to be negative infinity when we're doing increasing and decreasing. The right arrow is always going to be positive infinity. And then I label the points where my graph changes directions. So it changes direction at negative 3, at 0, and at 2. So time for a roller coaster ride. We're going to start here on the left-hand side, and this is going down, so this is decreasing. From negative 3 to 0, the graph is going up, therefore it is increasing. From 0 to 2, the graph is going down, therefore it is decreasing. And from 2 to infinity, the graph is going up, therefore it is increasing. So we're finding the decreasing intervals. All right, and I'm just going to make a list here of the decreasing intervals. Decreasing starts at negative infinity and goes to negative 3. All right, so I'm going to look for that one, and that is number 1. Also, I have a decreasing interval that starts at 0 and goes to 2. Therefore, this would also be an answer. So the correct answer on this particular problem would have been answer C, 1 and 5. The increasing intervals, even though it didn't ask, I'm going to go ahead and list those. The graph is going up from starting at -3 and ending at 0. And then the second increasing interval starts at 2 and goes to infinity.